we are making a triangle congruence graphic organizer. You can do this on a note card, a full piece of paper. We did a half piece of paper. My idea is that we could fold it in half and then sit it up on the desk, which you can't really see real well on the camera. But if you fold it in half and then you can sit it up like an A-frame, then it will be in front of you while you're doing your work. So that's your decision, but we're going to fill it out here. So we are going to add one new triangle congruence because it comes up a lot, but it's not one that we're focusing on. We're going to start with the obvious one, and that is side, side, side. And I say it's obvious because we don't have to worry about included or anything like that. So you're going to go ahead and sketch two triangles. You can make them the same direction. You can reverse them. I'm going to go ahead and reverse mine. Try to make them similar in size. Mine aren't perfect. And what I'm going to do is I'm going to mark that these two sides are congruent. I'm going to mark that these two sides are congruent. Remember, I reflected mine. And then I'm going to mark that this side is congruent. So I have to have three congruent sides. I know mine don't look perfectly congruent, but they're pretty close. And the fact that I mark them tells me that these sides are congruent. So with side, 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 we have three congruent sides. All three have to be marked. Three congruent sides. That is the big fact. Now, the next one we talked about was side angle side. So again, I'm going to draw these similar looking triangles the best I can. They're supposed to be congruent. And it's going to be side angle side. I'm going to make a note that it has to be an included angle. And that's why you guys have the highlighters. Has to have an included angle. That's key. So when I go to do this, if I mark this side congruent with this, and maybe this side congruent with this, there's only one angle that I can use. And it's got to be the angle, and this is why you guys have the highlighter. If you highlight these two sides, what angle do they form? Well, they form this angle right here, don't they? That's the idea. So if you think about these two sides, the only angle I can use is the angle that those two sides are there. That is your included angle. That's why it's so important. So I can't use any other angle. It has to be between the two sides. The included angle is formed by the two sides. So an included angle is formed by two sides. I'm going to say two sides marked. All right, so that's your SAS or your SAS. Next one is the flip side, angle, side, angle. So this time we have to have an included side. So I'm going to say the included side is formed by connecting angles. I think I could have worded that better. The included side is formed or is between the two angles. I guess I could have said that. All right, so I'm going to go ahead and sketch my triangles. Maybe I should have made this with the triangles in place. Sketch my two triangles. And if I mark this angle with this angle, and then I'll use this angle down here, there's only one option for the side. If you trace this angle, and then you trace this angle, do you see that the included side is between them? That's what's so important there. That is the included side. So you can't be bouncing around. It's not just any two angles in a side. It's two angles with a side that's sandwiched in between them. Got it? All right. Angle, angle, side. Angle, angle, side. So let's go ahead and draw our two triangles. And so if you look too quickly, you might think, oh, well, this is an angle, angle, side. You can't go angle around angle, side. The side has to be included. Angle, angle, side is two angles in a row and a side on the outside. So two angles, I'm going to mark these, and then a side on the outside. Now, honestly, I could have left this side and done that. It could have worked with either side, but it cannot be used here. So 2 angles in a row and then a side. 2 angles in a row, or consecutive angles, then side. So that's just sort of a quick reminder. Now, these are the 4 that we have focused on, and I think we're getting pretty good at them if we take the time and look. Here is one that I'm going to add because it came up a lot, and it's not something we're fully focusing on, but it's going to come up, and it's called HL. And HL stands for hypotenuse and leg. Hypotenuse, leg. But I'm going to add on, it's actually hypotenuse, leg, side. So you'll see it as HL or HLS. Now, for something to be a hypotenuse, it has to be a right triangle. That's the only one this will work with. So I have to change my drawing. And we talked about this yesterday. This little corner shows me that it is a right triangle. Okay, do you guys remember what the hypotenuse is? The hypotenuse is the side opposite. So hypotenuses have to be congruent. So this is your hypotenuse. It's the largest side of the triangle. It's opposite in the 90-degree angle. And then you need one leg. This side, either of these are legs. So legs come off the 90-degree angle. So if you have a right triangle and you have a leg and a hypotenuse, you have congruent triangles. Now, if you really look at this, it does spell ASS, but we can't use that. Remember we talked about how you can't use ASS or SSA? So that's the idea, but if it's a right triangle, we can. All right, there's one more I want to tell you. This is what we can use, but there's one more that you can't use. So I'm going to write AAA, and I'm going to cross it off. AAA is not a triangle congruence. Here's why. I want you to just think about this. I drew this triangle right here for you. Got it? Here it is. This triangle is the same proportion as the one on my screen, but it's a lot bigger, isn't it? Because I've projected it. But the angles are the same. So I can draw 2 triangles. Let me draw this one. I'm going to try to draw a bigger one that looks similar. And this angle could be, I don't know, we'll say 40. And we'll make this one 60. And that will leave me 80. Oh, that better be 60 in there. 40, 80. Do you see that I have, that's supposed to be 60. Do you see that I have 3 congruent angles? Are my triangles the same size? So this is called triangle similarity. So angle, angle, angle is not a triangle congruence. It can prove that you have similar triangles. So I don't want you to get fooled by that one. All right, so this is not a triangle congruence. That's why it's at the bottom there. This is our newest one. So keep this sheet, and we're going to use that.